So fractions section 2 is all about adding and subtracting them. And the key concept to remember here, that whenever you try to add and subtract fractions, you need a common denominator. And that's what you should be thinking for all these questions. Okay? So, if we have a look at this numerical examples first, and then we'll go on to the algebraic ones. So we've got 3/5 take away 1/7. Essentially what we need is the LCM, the lowest common multiple of the two denominators you've got. So what number can you divide by both 5 and 7? Well, the answer is 35. So in order to get this one into a fraction out of 35, I need to times top and bottom by 7. And in order to get this one into a fraction out of 35, I need to times top and bottom by 5. So it gives me 21 minus 5 out of 35, 16 over 35. Okay, you have a go at yours. So you should have got that your common denominator is 36. So top and bottom of this one by 9, and top and bottom of this one by 4. So the answer is 29 over 36. Now you might have been tempted in that process to do something like this. This kind of bow tie thing, this idea of timesing both parts of that by that, both parts of that by that. Now that's fine, provided these two don't share a factor. But if you do that on the next examples, you actually make your life more complicated. So think about the common denominator here. We've got a third and we've got a ninth. What number can will both of these go into? Well, the answer is 9. Okay, so we can leave this second fraction exactly as it is, times top and bottom of this one by 3, and it gives us 3 plus 1 over 9. So that one is 3/9, that one is 1/9. If you do it this way, you end up multiplying these together, so you end up with your fraction out of 27. And I know 27 isn't the biggest number in the world, but it can lead to some horrible numbers, and more importantly, to some horrible algebra later on. When you do the algebraic fractions. So be thinking about what is the common denominator, what is the LCM. A common mistake at this point is to say, well, I've got 3 and 9, so I'm going to write both fractions out of 3. You can't do that. You can write this one out of 3, but if you want to write this one out of 3, you then end up with like a third out of 3, so it just doesn't work. Okay? So if they share a factor, you've got to kind of go for the higher number effectively. Anyway, we end up with 3 plus 1 over 9, which is 4/9. The other advantage of this is that you then don't have any cancelling out to do at the end. If you'd done it all out of 27, you'd need to cancel your answer down. Okay, so see if you can do this one. So 4 and 8, what number do both 4 and 8 go into? Well, the answer is 8. So the second fraction can stay exactly as it is, but we need to times top and bottom of here by 2. So we get minus 1 over 8, and it is a negative answer there. Third one is similar kind of scenario, because these two, the 2 and the 4, don't times them together and do the whole thing out of 8. But we've also got a whole number here as well. So again, be thinking, what's the common denominator? Well, I can get everything out of 4. So 2, so I'm going to do everything out of 4. 2 I can write as 8 over 4. So I'll just times it by 2. A half I can write as 2 over 4. And a quarter is already 1 over 4. Okay, so 8 minus 2 is 6, plus 1 is 7, so the answer is 7 over 4. Absolutely fine to leave it like that as an improper fraction. Notice we've got a little bit of a kind of misconception that sometimes people make with things like this. They remember the acronym BIDMAS and say, well, I do my adding first, so that's 8 minus 3, because 2 add 1 is 3, which is 5. That's wrong. And even though you might be able to do 8 minus 2 plus 1, it's tempting sometimes to look at this and say, oh, well, okay, well, I'll do the half plus a quarter bit first, and then I'll take it from 2. But that's wrong, because you've just done that, which is not the same as that without the brackets. So, again, just the kind of easiest way to avoid it is think common denominator. Have a go at this one. Okay, so your common denominator here is going to be 6. 1 is 6 over 6. 2/3 is 4 over 6. And 1/6 is 1 over 6. 6 minus 4 is 2, plus 1 is 3. So your answer is 3 over 6, which is a half. Okay, so those are your numerical examples. Key things to take away. You're looking for the lowest common multiple, and you're looking for this common, write everything over that common denominator. So on to the algebraic examples then. So the first one of these, we've got, instead of numbers now, we've got algebraic terms. So here we've got x plus 3 and x minus 1. Now these don't share a common factor. You couldn't factorise anything out of both of them. They've both got an x in, but remember that's not a factor. So this is like our first numerical example. We say these two numbers are co-prime, they don't share any factors. And this is the same here. So what we need is our common denominator is just going to be these two things multiplied together. Just like up here, it was these two things multiplied together. And in order to get that, we need to multiply the first fraction by x minus 1 and the second fraction by x plus 3. Tidy that up. 2x minus 2 minus 4x minus 12. Don't forget the minus 4 times the plus 3 gives us a minus 12. There's absolutely no need to expand these brackets on the bottom. Leave them factorised. Like I say often in A-level maths, factorised form is better anyway. So we get minus 2x minus 14 over x plus 3, x minus 1. And if we really wanted to, like I say, factorising is good, so we can actually pull out a factor of 2 on the top. I'll rewrite this as minus 2 times x plus 7 over x plus 3, x minus 1. We can't actually do any cancelling down here because we haven't got any common factors, but sometimes that makes that a little bit easier to deal with. Okay, so you have a go at your one on the right. Change colour because my pen is running out of it. Hopefully you can see this yellow okay. So we're going to do our common denominator as x minus 2, x plus 1. So we need to multiply this one top and bottom by x plus 1 and this one top and bottom by x minus 2. I'm going to do all the terms in 1, so 3x plus 2x is 5x. And then we get a 3 minus a 4 minus 1 over x minus 2 x plus 1, and that's it. We can't factorise, we can't cancel down. This next example here is a little bit more like this one. So here 3 and 9 they share a factor, so the LCM is not just these two multiplied together. And here these share a factor. That's x plus 3, that's x plus 3 squared. So what we can do is write both of them as fractions over x plus 3 squared. If we times top and bottom of this one by x plus 3, we get that, which hopefully you'll agree this would cancel down to that. So these two are equivalent. And this one is already over that x plus 3 squared, so that becomes a minus 4. So we get, and again I won't bother writing it out in full, we get 2x plus 6 minus 4, so plus 2 over x plus 3 all squared, which if you really wanted to factorise the top, always a good idea to factorise, like I say, where you can. Okay, you have got this one. So here our common denominator is going to be x minus 2 squared. Notice that don't make it x minus 2 cubed. If you just multiply these together, you're going to get x minus 2 cubed, and you end up with multiplying this by x minus 2 and this by x minus 2 squared. So you end up with this quadratic on the top that you don't need, and it will all cancel down eventually to this anyway. So you're going to introduce more difficulty and lead to a thing which is hard to cancel down, which is why you want to keep everything as small as possible. Here we can deal with the number 27 and cancelling down, but here we're going to end up with cubic and quadratic expressions. We don't know how to factorise cubics and cancel them down yet. Okay, so keep it all nice and low. So this one needs multiplying by x minus 2, and that one is already over x minus 2 squared. So that's going to give us 3x minus 6 plus 2, so it's minus 4 over x minus 2 all squared. And no common factors in those two, so we can't factorise any more there. Okay, the last example then is the biggie. Okay, so again, we need to think really carefully about what our common denominator is going to be. We've got x plus 2, x minus 1, x plus 2 and x minus 3. Okay, now these have a common factor, the x plus 2. So we don't need to multiply these two together to get an x plus 2 squared. And in fact, what we should be able to do is get the whole thing over x plus 2, x minus 1, and then x minus 3. Okay? So, the 2. We're going to need to multiply the 2 by all of these brackets. X plus 2, x minus 1, x minus 3. Again, you hopefully agree with me that that would currently cancel down just to that. This second fraction, in order to get it over this denominator, would just need multiplying by the x minus 3. Again, if you look at this term, if you were to cancel it down, they'd go and leave us with that. And then the 3, we're going to need to multiply that one by the x minus 1. Okay, again, if you were to cancel it down, the x minus 1, x minus 1, so it would leave us with x plus 2 and x minus 3, which we've got there. Okay, so that's a pretty complicated looking expression. We can't do anything with this other than now just expand it and start collecting terms together. Okay, these 3 don't share any common factor that we can pull out of everything, so let's just expand. So here's what I'm going to do. Here I've got 4 things multiplied together. 1, 2, 3, 4. So I'm going to multiply the first 2 of these together and the second 2 of these. So x squared minus 4x plus 3. You might want to draw a grid on the side if you're not happy with that. And I'm going to expand these, so minus 5x plus 15. Be careful of that minus times a minus. Plus 3x minus 3. That is all still over x plus 2, x minus 1, x minus 3. And now I can expand these out. And again, you can draw a grid on the side if you want, and I'm going to do it sort of just kind of longhand. So I'm going to get 2x cubed minus 8x squared plus 6x. So that's multiplying everything in this bracket by 2x, and then everything in this bracket by 4. So plus 4x squared minus 16x plus 12. And then we've still got minus 5x plus 15 plus 3x minus 3, all of that over x plus 2, x minus 1, x minus 3, and now we can collect terms together. So we've got 2x cubed minus 4x squared, we've got 6 minus 16, so that's minus 10x minus 15x minus 12x, and then the constant is 12 minus 3, plus 9. Okay, let's just double check by it can help to cross them out as you do them. So we've got the x cubed, we've got minus x squared plus 4x squared, it's minus 4x squared. We've got 6 minus 16, it's minus 10, minus 15, minus 12. And then, see, this is why you check, because I've missed that 15. So 12 plus 15 is 27 minus 3, so that's 24. Okay, and then that's all the terms there, and that is all still over that. X plus 2, x minus 1, x minus 3. You might notice here, the one where we couldn't neaten this up is everything's divisible by 2, so we can take out a factor of 2. X cubed minus 2x squared minus 6x plus 12. X plus 2, x minus 1, x minus 3. And that's as far as we can go with that until we learn how to factorise cubics. Okay? Notice that I only did all this expansion here because this was not in factorised form. We had 3 terms on this top, so it goes back to that definition. There's a term, and there's a term. Okay? 3 terms on the top. We couldn't factorise, so we had to expand and collect. If all I had on the top was a load of brackets multiplied together, there'd be no point expanding them out. So notice I haven't bothered expanding this denominator as a cubic because it's more useful in factorised form. Okay. So you have a question on the right hand side of the page. See if you can get the same answer. Pause it. Okay, so here we go then. I'm going to get myself a fresh piece of paper, I think, because I've come onto this side of it. So our common denominator is going to be x minus 4, x minus 3, and x plus 4. because we've got that bracket repeated, the x minus 3. So the 1 is going to have to be all 3 brackets together, minus 4 lots of x plus 4 plus 2 lots of x minus 4. Expanding these out, so expand 2 brackets first. X squared minus 3x minus 4, it's minus 7x plus 12. And again, do the grid at the side if you want. Minus 4x minus 16 plus 2x minus 8 all over those 3 brackets. Expand these two, so multiply everything by x squared. We get x cubed plus 4x squared. Multiply everything by 7x. And multiply everything by 12. Again, the grid is really useful here. There we go. And now we can start collecting terms together. So we've just got the 1x cubed. We've got 4 minus 7, so minus 3x squared. Minus 28 plus 12 is minus 16. Minus 16 minus 20x minus 18x. And then the numbers, 48 minus 16 is 32, and then minus the 8 is 24. I think that's right. Okay. All over x minus 4, x minus 3, x plus 4. And that's it. And like I said, so until you learn, we can't factorise anything out of here. Here we had a 2 we could take out, but here we haven't. Until we learn how to factorise cubics, we can't go any further with that. But I think that's far enough. I'm sure you'll agree. Okay, so have a go at the questions in this section. Remember, common denominator. As hard as that was, think how hard it would be if we'd multiplied all 4 of these brackets together and ended up with a load of stuff to the power 4 on the top as well. Okay, this is why you want to look for those common factors and think, what is the lowest I can get away with on the bottom? What is the least I can multiply top and bottom of each fraction by to get them all over the same thing?